See what you're saying. Thank you.
Yeah, I went ahead and started the recording. Those are great questions, David. Very good questions. And I'd like to thank everyone for coming out today. Hey, Lamont, it's good to see you as well. It's good to see everyone. And definitely let's thank GLM for showing us and walking us through today's presentation.
Thank you, Texas. Yeah. This is my first time doing a blockchain related presentation. And so please be kind. I am an experienced coder, I would say. I'm more like I work during the day, I work with ETL, take data from here and put it over there. But maybe a year and a half ago, I got into blockchain. I had been a miner a long time ago. And so I was a gamer, led to mining, and then I got curious about what was actually going on and just decided to learn. So figure what we'll do today. The contract we have is a simple contract, but I really want to get into, like, even if you're not here to actually learn how to code a contract, if you take away just like how to read a contract on like Etherscan, or if you are just a little bit more confident in sending a transaction through a Web3 wallet, like, and you're just kind of a little bit more aware of what is going on as your money has left your wallet, or you click a transaction, you're like, what is going on? And also, when you don't really know what happened, how to parse through the data that's given to you, I think is a big thing. So again, please feel free to stop me at any time. I think definitely prefer just conversation, any questions. And I figure, thank you for everyone for coming. I recognize some faces and appreciate you showing up on a Friday night. Definitely some really, really smart folks I've seen around EthBuilders, as well as some people from the communities that I've been involved in. So again, thank you for showing up, spending your Friday with us. Let me introduce you a little bit first to what I want to show you, and then I'll give you like kind of an agenda. I'll introduce you to what we're going to do, kind of the tools we're going to use. And then I do have like a YouTube video that basically goes through this, but I've learned some things since I made the video, and I will kind of move it. We'll watch a little bit of that, so just give it a break from me talking, and we'll go along and stop me if you want to talk about a certain topic at any time. I'm going to start sharing my screen. Okay, can you see my Chrome?
Yep, I can see your screen.
Cool, thank you.
It's under the middle one.
Good guess. Cool, thanks. So a little bit of history here. I made a contract not knowing what I was doing, because really the genesis of this idea was I'd been wanting to learn blockchain for a long time to a more kind of intimate level. And I played a small little game wherein it was similarly a chance-based game, guess which one of these things is something. And I was actually able to guess correctly by kind of clicking my guess and then observing the amount of gas it was charging me in the wallet, and just kind of canceling the transaction and starting doing that until I found a different number for the gas. And it triggered my interest into like, well, okay, that is interesting. It's not a good game if a user can do that, but also like, what does that mean for someone designing a smart contract? So I'm going to play a little bit of this, just it's a little bit easier. And again, stop me if you want to at any time. That implements a shell game. It's a picture here. If you don't know what a shell game is, it's basically a simple betting game where there are 3 shells, and under one of these shells, there's a pea or a ball. And if you guess which shell,
Yeah, we lost sound for a second.
oh, you did?
Yeah,
Back now.
Oh, okay. Yeah. It's kind of an intricate setup. That's no big deal. I can go through it. Can you hear me now? I'm talking live.
yep, I hear you.
Thanks. Okay. So what I say in this video is basically we're going to use this chain IDE, and let me exit out of it so you can see what this looks like going from, brand new user. So what this is it's an online app. Say try now. And I have some projects here. I'm just going to open one. And what I can do is I'm actually signed in with my GitHub account. That's how it knows like I had something before. It has my saved stuff. But basically, if you're familiar coding, think of this as like a VS Code editor in Chrome. It's all in Chrome. But it also gives you kind of a there's a full Linux shell available to you. So terminal. And again, I don't really use it like that, but it gives you all of these software packages that you might see in other beginning tutorials where the first step is like execute this command and install all these packages. Kind of the point here is to get past that and just focus on what does the code look like and what does it actually do. So again, I learned from a bootcamp using this, and I've been able to do a few interesting things without ever installing like the standard Ethereum tools on my computer. So if that's the route you want to go, it's an idea. Let me introduce the code in our contract. So this is our contract. It is these 3 SOL files, and I'll explain what they are later. This one really is like my code. And what this does is implements the shell game I was talking about earlier. And since the video didn't run, I should explain what that is. Shell game is basically, you've seen, maybe you've seen it like on the street with solo cups. It's basically a chance-based game where there are a few shells, and under one of those shells, there's like a pea or a ball. And if you guess the right shell that has that pea or ball under it, you win. Very simple. So in this case, it's really just a math game. So you have a 1 in 3 chance of winning. But as you'll see in our contract, in this case, if you were to pick the left shell and turn it over, the game state stays. So obviously, you can guess again, and you can guess the right shell. And then when you turn over the right shell and you don't find the ball, you're like, okay, I'm going to guess the middle shell, right? So that right there is just, it's worth mentioning that this is kind of a game that has multiple steps to it. And when we look at the code, that'll be kind of the focus of what's going on. So over to our code. If you've never seen a contract before, basically, this is the definition of it. Actually, I'll walk through kind of each line very quickly. This pragma line just kind of tells the compiler like what version of the software am I going to use. And this import statement, I'll explain what that does later. It's going to basically import this other file. And in here, contract shell game, this is my code. In here, and these three items that we put inside of this, of like these curly brackets here, is basically setting it all up. Is as soon as I deploy this contract, this is going to get initialized, this is going to get initialized, and this one as well. And then when we actually, sorry, the constructor is actually what gives it values when it is deployed. So we declare these three things up here. And then when it's deployed, it goes, okay, I'm going to give a value, right? 1, 2, 3. It's just a little, I mean, nothing special there. It's just a little bit different than like if you were running code locally with some traditional programming language. Any questions about anything that's going on so far? Cool. And again, stop me anytime, because I don't want to bore you guys by kind of talking about the code for too long. So what are these things? Our range is, in this case, just going to be 3. It represents our 3 shells. Our number is going to be a randomly generated number. It's essentially the ball. And what we do is when we kind of modulus it by the range, we're going to end up with, in this case, because we're using a range 3, we're going to end up with 0, 1, or 2. And that right there, that map is what is going to drive the game, is pick a number between 0 and 2. Right? It's not complex at all. This event is basically going to output an event that we can then read on the blockchain after it's executed. More on that later as we actually look at the data. This one is just kind of like something you can put in here that says, I want this contract to be able to accept a normal transaction. This random int is how I'm generating this random number. This is standard. I Googled it. There are better ways. Like this is a decent way to get a random number. But like if this was going to be a game where people were playing with real money, I would probably want to use something like an oracle here. Because really smart people might actually be able to understand what, they'll be able to guess what the random number is. Because again, they're going to be able to see this on the blockchain. This withdrawal statement is basically how we're going to send money back to a winner. I don't think we should go over kind of all the details of what this does, but basically in this message object is going to be the person or the address that sent the transaction. So it says, okay, if you want to send crypto back, you say, okay, give me the identity of the sender and call this with some winnings. Again, let me know if you want to come back to any of these concepts. I'm going to be quick. And this guess here is kind of the meat and potatoes of our logic. So someone is going to send a transaction to this contract, and we're going to require, in this case, that they send 1. It's CFX because we're going to be using the Conflux Network blockchain, but you can also see it's called Ether. That might be confusing. As you can see, Ether is actually like a symbol that the language understands, right? Because Solidity was written for Ethereum, by Ethereum. So if I type something else, it turns white because that's not actually a symbol. Win, this is going to be a Boolean, true or false. And winnings is going to be how much are we going to send back to the user. So basically, if the number, again, this is the number that sits in the contract. This is the winning number stored locally. If it's, if 0 equals the value that the user is sending, that's their guess. If 0 equals 0, right? That's a win. Kind of common sense. And basically, this is what we want to do if it's a win. We say first, we need to reset our game, right? Because they found the ball. We need to start another game. This reassigns the value of this to pick a new random number. We say win equals true, and we're going to send back 2 ether. Again, if this was going to be used in some kind of production capacity with real money, you probably want to figure out the math behind what is the probability of winning this game. And it's a little bit complex because it's in the first try, it's 33%, but on the second try, it's actually 66%. So somewhere between those numbers would be what you would want to set that. Where were we? So that's the winnings, and then we call that withdraw statement or withdraw function that we defined earlier. So that's if you win. Now, what happens if you lose? Right? I should just do nothing, right? But we actually want to do, in this case, the same amount of computation and storage that we did for a win. But why, right? Remember what I was saying before about when you send a transaction, or I guess before you send a transaction, when you kind of loaded it into your wallet and you're going to click confirm, it tells you what how much gas is going to cost you. This is what the game that I played before didn't do. Is in the case of a loss, they just kind of said you lost, and I was able to tell the difference between a winning and a losing bet. So in this case, we use this kind of, again, up here, it is referenced as a useless number, but its true purpose is to cost gas. Is when a winner, when someone submits a winning guess, we have to reassign this value, and that costs gas. It really costs like storage cost, but it's going to cost the user. So we need to just kind of do the same thing in the case of a loss to equalize the gas usage. Win equals false. Winnings is 1. Now, why do we care? This actually could be 0, but I just made it 1. Keep in mind that this 1 is like 18 zeros. It's actually equivalent to like one GUI on Ethereum. And this 2 is really equivalent to like this integer, making the same length, if that makes sense. Again, just because this is a symbol and the language understands what it means. Get rid of those. And then we again call withdraw, just again to match the amount of computation that a loss consumes with the amount a win consumes. And then after all that, we emit this guess event with some data, right? I'll show you why after. Some utility functions exist down here. It's kind of like, okay, this exists so that I can show you what the winning number is while we do this. This is only available to me because I am going to be the contract owner. So another user wouldn't be able to call it. And I think this one also is. only for owner is to set the range. Like if I say the range is 10, then equivalent, what that means is we have 10 shells in our shell game. If I did do that, then probably I would want to change the amount someone would win if they actually guessed right. But I purposely have kind of kept this in what I think is the simplest form. So again, this is really a teaching tool. It exists for this purpose. There's some clear enhancements that could be done on this. And if you want to kind of talk on that later, we could, but for now. Oh, I should explain the only owner. So this, the ability to restrict calling this to only the address that is the owner of the contract comes from these contracts. Yeah, these are, I don't even know what these do, but I know why they exist. It's to provide that only owner ability. And these are both these are from OpenZeppelin, this ownable and this context. Again, this kind of like, if you're familiar with other languages, just importing a library from a package manager. It's really the same thing. So let's stop looking at code and let's do some blockchain stuff. Okay, what I'm going to do is I want to deploy this. I'm going to go over here and click deploy. No wallet connected. That's right. So I'm going to click connect wallet. This is like MetaMask. Now, I could use MetaMask if I was going to deploy this to Ethereum. I'm using this other wallet called Fluent just because of the blockchain we're choosing, which is Conflux. So I'm going to say deploy. And this really, you can just think of this as MetaMask. It really operates exactly the same to the user. So let's say it's going to cost me 1.75. CFX in this case, think of it as Ethereum. Cool, it worked. We didn't break anything. So let me pull this contract up and then maybe we'll take a little break, talk about any questions you have so far.
Okay, that sounds great.
Thanks. Again, that was a little bit in the weeds for what I wanted to do, but I think it's necessary to just kind of step through it. Okay, so this is a test net. So always do stuff like this on a test net. And okay, cool. So our contract is here. It has this address. I'm going to copy that. Let me go to the contract. Nope, that's me. So again, this is our contract. Doesn't have any transactions yet because no one's interacted with it. Doesn't have any, currency in it. Shouldn't be anything here. And look at that, it actually is. Huh, it's verified. It's weird. I didn't expect it to be verified. I'm sorry. I don't know how that actually happened. But I wanted to walk through kind of a verification, so. Let's see if we can do that again. I honestly don't know why that is verified. I think maybe because it has like the same signature as something I've already deployed. So I'm sorry about that. It's kind of throwing a wrench in what I want to talk about, because I've deployed this a few times. Let me try something again. Just gonna add this. Pointless. So why am I doing that? This should change the kind of signature of it, of the contract as a whole. And then I'm hoping it actually doesn't verify when we deploy it. Now, does anybody have any experience kind of going on, going on an Explorer like Etherscan and then seeing a contract and it's actually not verified? Because that is something I've experienced, and it was very confusing to me at the time.
Yeah, Lamont, have you seen that on Etherscan?
Hey guys. Yeah, I have. Off the top of my head, it for the most part, I don't necessarily think it's something you should worry too much about. But yeah, I mean, at least if you're doing it locally and you're not necessarily planning to like deploy it out onto the mainnet, but you do want to make sure that yeah, contract is verified in terms of I believe this mostly goes back to whether or not it's actually came from the like the original well, who you meant it to really come from, I guess. Yeah, do you feel me? So
Yeah.
Yeah.
Okay.
Is that similar to when you see the bytecode at all and the contract has to be redeployed?
I think yes.
Okay, because I was noticing when they did the fork over to ETH proof of work, right? I was going to some of the contracts and looking at contracts, and you could see the bytecode, but you couldn't actually interact with the contracts, even though the contracts were deployed in there. And so you'd have to redeploy the contract or something like that, or verify it.
Yeah.
Yeah, that means it's not very
Okay.
Yeah. Okay.
Yeah. Okay. I'm sorry. I figured out why. I did not recompile my contract. Without going into too much detail, when I was clicking deploy here, it was actually deploying kind of an already compiled version of the contract. In essence, the changes that I had made were not part of it. So I just recompiled it, and I'm going to deploy it because I do want to show you guys what an unverified contract is, just so we can really understand what's going on with like on the Explorer itself. $708, that's now. Just gonna wait for it to confirm.
Is this just a test net or is this a separate sidechain?
Yeah, it's just a test net.
Just test net. Okay.
So like, I've deployed this like 10 times. But actually, I should probably go to the contract already. There we go. This is what I want to show you. Confirmed contract. See, now we don't get any information about what is actually in the contract. And let me do something from inside Chain IDE. So this app has a way to actually interact. Right here. So, oh no, what did I do? It had a way to interact. Down here. Okay. Close this. Now, what we just deployed starts with ACD6. Or it ends with OB4F. Let's just confirm. Yeah, okay. So in the tool, if you remember before I said like there's some special functions where I can say, I want to know what the winning guess is, right? I can do that in here and it knows, that this is a function called get number. I'm going to get it and it's going to tell me the answer is 0. But I can't do that from here. right? Because this app, you know, the actual website doesn't know what you can actually send to this contract. That's because inside of Chain90E, it has what's called the ABI. And I need to try to find it somewhere here. Essentially, it's bytecode. And you don't need to know much about it, but essentially it's like a schema. If you've ever worked with messages, it is a way for the sender and receiver to understand like what are the limitations on what you can have in this message, and also when you send me a message with a certain transaction, I know what to do with it. So very quickly, we can go over here and say, I would like to verify my contract, please. And what this is you're putting the source code, you know, into the website so it can then generate its own version of that ABI. So this thing is called shell game. Let me just double check. This is what matters. Yes. License is MIT license. It's kind of the standard open free. This is going to match whatever I have here. This means anything greater than 0.8. So this should be fine. Don't need to do this. Don't need to do this. Now, when I try to upload contract file, it's not going to let me just upload this. And this is something I want to talk about. It's if you've ever heard of flattening a contract, or you've ever heard of hard hat, please let me know. But basically, what we need to do is we need to collapse these 3 files into a single file, paste it in here. Now, I've done it via hard hat before. Essentially, there's a shell script that says, get all the files that are referenced here and just kind of squish them into one file. But again, we're getting focused on just like getting it done, getting started, learning. You can actually do all that right in here, or really in any text editor. What you can't do is you can't import. So this line, even though it's commented, is actually important. There can only be one of them. What I'm gonna do is under here, I'm gonna comment out this. And guess what I'm gonna do? I'm gonna copy this. Just paste it in here. And why did you do it at the top? Is you need to basically faithfully represent what would happen. You preserve this import order. So shell game was importing ownable. So I pasted it here. And ownable imports context. So what I'll do, this is the back in the main contract, comment out the import statement. Now, this is probably not the greatest, but it's okay to have multiple ones of these. There you go. Copy this into here. I may need to actually keep these in line with like the contract definitions. I'm not entirely sure. But I just wanted to show you guys, like, if there's any this is definitely something I know from myself and a few others. Like, as you're learning, you want to get into learning this. Flattening a contract and using like a shell script to do so is something that stops people from learning occasionally. So here, I can just do it in one file, paste it in here and submit. And thankfully we verified. So now I'd like to go back, please. Now the contract is viewable here, which is good, right? That's what you usually want to see. Our contract, but probably more importantly, users can make calls into the contract right from here, right? And a lot of people do this. I enjoy NFTs, so there was an NFT like minting that happened a few days ago, in which there was a problem with the website they had set up to do it. And it was a big problem for users, but those who kind of knew were able to come to, as long as they had the contract address, go to Etherscan and basically, mint their NFT from here. And it's kind of good practice for something like that. Even if you don't really understand it, just take a browse at the code. Try to see what it's doing. That's honestly how I learned some of this stuff. And so what we did before, we said get number. Oh, caller is not the owner. That's good. And that is because I'm not connected to Web3, I think. Don't really know how to do it here. Sorry. Some hiccups today. But we could call all these from here. So why don't we do it from chain IDE first? Again, I've been talking a lot. Does anybody want to take a break, talk about any of the concepts that have come up in detail, or just talk about your experience?
Hey, what's going on, man? I just got a quick question for you. Your main function down at the bottom going for the win. Would you mind going through that real quick? I don't think I got a chance to hear you go through it. Yeah, function guess.
This one?
Mhm.
Yeah, sure. Thanks. I'll go quick because some have already heard it. Basically, this is the entirety of the contract as a user would probably use it, right? It's probably easier to look at it here. Guess. So a user is going to say, they're going to guess a value. It's going to be an integer. And we know it's going to be between 0 and 2. There's nothing to prompt the user, right? That would be an enhancement. I would definitely put in this to say, user, you have to guess 0, 1, or 2, right? But basically they're going to guess 0, 1, or 2, and then it's going to go into here, simple if logic. And if they win, it's going to first reassign the winning number so that the game is playable again. It's going to set this win Boolean. It's going to set a winnings variable to 2, like 2 ether. And then this withdraw function is what is actually going to send it back to the user. And then in case of a loss, one thing we were focusing on before is in case of a loss, like why do I have to do anything, right? I could just kind of leave it like this and a user could just kind of not get any money back, but that's not a great experience. And also these really exist to balance out the computation and the storage, the actual values we're going to store on the blockchain for both a win and a loss. And do you want me to go into why?
I mean, I'm good. I get what you're doing. But does anybody else have any questions?
Yeah, there were a couple questions in the Zoom chat. Stephanie just posted one also, and then Orion posted one as well.
Let me stop share for a couple minutes. Can we go through some of the most used variables or commands in a contract? So we know what they are when we read them. That's a good question. Most used. I don't know if I could comment on most used, but I know we have some very smart individuals here, and I'll do my best to maybe explain some simple stuff like, get back to Chrome. Like some of the definitions up here, right? And these are concepts that exist often in from traditional languages. It's like public means that any user, like a user from outside the contract, can interact with this. I believe there is a private. Oh, I see. It's internal. Equivalent from like Java or like Visual Basic would be like private. This is an internal function. So like a user couldn't say, hey, withdraw 10 ETH. Only the functions that exist within the contract can actually call this. Is that something you find valuable, or are you more thinking for like specific variables and usage patterns?
Yeah, I mean, I guess my question was just like, if I'm new, which I am, and trying to learn by reading these contracts, like what are some things to look out for? Whatever you think, like that information you just gave was valuable. So any key things that you think are good to know? Obviously, every contract is different, but yeah, anything like that.
Okay. I would probably say you'll see this a lot, MSG. That is kind of the context variable that's given to the contract. And I'm not all that aware of everything that's in it, but you'll definitely see this in most contracts. And for me, learning, like what I do basically is Google how to do something and get a line of code, try it out, and then kind of go into look for enhancements. Like I know there are things that are very important in the blockchain that I don't fully understand yet. Something like reentrancy guard, which is similar to one of these contracts. It's like a standard OpenZeppelin contract wherein they've made a nice convenient library so that if you use it in the established way, you are protecting yourself from like common attack vectors, I guess people would call it, common ways that people would try to game or, cheat. Does that help? Actually,
Yes, that's helpful. Thank you.
Yeah.
sorry, like I said, I'm not all that advanced at Solidity myself, but this is probably good advice. Look at the OpenZeppelin contracts. If you go to OpenZeppelin.com or .org, I'm not really sure. These are industry standard accepted contracts. I don't know exactly how to get to them. Learn. It would be somewhere. Let's get to some contracts. Somewhere on their website, they'll have a list of their libraries. And, my code was written really for this purpose. I was hoping to kind of learn from it and to be able to share. I wouldn't copy my code, but I would copy these or study these contracts, right? Because these are going to be written by experts and kind of peer reviewed. That's probably all I would be able to help you with that, if that helps.
Yes, thank you. I'll do more research. Thanks so much.
Cool. Like for me, when I was making this, I did it without these. Well, I did it with just kind of a basic public function first, because no one's going to be calling my contract. I didn't care. But I just kind of said, okay, I Googled how should I protect my contract from others. Because in this case, like I want these functions. Like I don't need this function if this was to be productionized. It doesn't really need to exist. I would get rid of this. But I would probably preserve this. Maybe I want to change the game someday. But if I did, I would definitely tie like the computation of the winning number to the actual range, right? If I change the range and if there's 1,000 shells and you guess 900 times, you probably want to win a little bit more currency for your work, right? Simple stuff like that.
Yeah, Lamont mentioned public, private, external, internal view. And then Keith had a question. I hope I pronounced that right. He had a question too. And then Charles would be next after we answer his question.
Great.
And sorry about that. I was getting confused with the hands up. I didn't realize it until a few minutes later.
Oh, no worries. No worries.
How do I get back to the chat? I'm sorry, guys. I'm
We're
going
all
to stop
here
the
to
share just so I
learn.
can see the chat. Thank you, Lamont. Yeah.
Mr. Bachelor, do you want to go ahead with your question?
Thank you. Thank you so much. Can you hear me?
Yes,
Yeah,
we can.
Okay, great. I just had a quick question in the beginning, and I appreciate your description. You described the UN 256 as something that declares, and the construction, or I'm sorry, the constructor as something that defines. Did I get that right?
Okay. Here, let me upgrade at this. Yes. So again, my understanding of it is the declarations. It doesn't really help if I'm not sharing, right? The declarations at the top are just kind of defining this variable with that name and the type, right? And then this constructor inside here is what will assign them values.
Thank you. And one more. You said the fallback was important for something, and I forgot to make note.
Okay. Yeah, and this is where, so I believe this is even maybe not the most modern way to do this, but what this will allow you to do is, or it'll allow the contract to basically accept a transaction if you're just going to send it some coin. So, and I believe the underlying detail is that's essentially a transaction with no call data, and the contract wouldn't really know what to do with that if you didn't provide this or something equivalent to, like, what do I do if I'm sent coin and, you know, no other instructions on what to do with it. So in fact, I can actually, there was one more question. So I'm going to read it here because I'm not that great at Zoom. In addition to public, oh, thank you. That is a statement, right? Not a question. These visibility modifiers are related to inheritance. Oh, see, I did not know that. So internal is the same as private, except that it is also accessible to contracts that inherit from this contract. That's an important statement. So was it the withdraw that I mentioned earlier was set as internal. And then, so if we had set it to private, then a contract that would inherit from this could not call it. So you wouldn't really, it doesn't matter for our contract, but it allows you to set like your access protection, right? And those are all concepts that kind of come from like object-oriented code. So if you know any if you're familiar with that or any study materials that are related to like those access modifiers, pretty much are going to help you with Solidity. Here. If there's no other questions right now, I would like to send a couple transactions and look at what that data looks like on the blockchain, because I think it's illustrative. So.
I do have a question. Can you hear me?
Okay. Go ahead.
Yeah, because I was a little bit late. I wondered, like, did you use any template in the platform, or like you just like import like another like your own code?
I did actually start with a template. There was a template on here called storage, and actually, it was quite basic, and then I extended out from there. So if I say new project, and again, not to be too much about this actual tool, it is a tool, but it definitely helps storage. Definitely helps you kind of take care of some of the complicating factors so you can focus on one thing at a time. Yeah, this is what I started from.
Or okay, I got it.
Yeah. Like in this case, all this contract does is define this uint number variable, store and retrieve, and just gives you kind of store and retrieve, which are like getters and setters essentially. But even I learned from this, because what's really interesting to me about blockchain is like, this is code, it's deployed to the blockchain, but like, where is this stored? Like, right? And this is actually what you're paying for when you set a value for number. Like, you have to pay a storage fee. But when you retrieve it, you don't need to. And as Lamont mentioned earlier, like, that is the difference between a view and I forget what the other one's called, but like, this can be called without a cost, if that makes sense, because it's not actually going to change the state of the blockchain. So it's not going to cost you that storage fee.
Okay, I see. Thank you.
Sure. Yeah, and thank you for bringing that up, because I had forgotten kind of where I had come from with this contract, because you know, my contract is just so advanced, right? Where were we? Shell game.
And I believe Charles had a question, or maybe I forgot to lower his hand, but I believe Charles may have had a question as well.
Well, not a question, but two statements. First of all, when you were talking about the BSD license, just because you described it, I think the main reason, the main use of it is you do not have to include the source code. You can just include the binary distribution. And the second thing, unlike the GNU license, and the second thing is, it was one. Yes.
I'm sorry, you cut out there at the end. I was just agreeing with you, and thank you for refining.
Yeah, no problem. And the second thing is this: there was a lady, I think a lady's voice on there, and she's talking about trying to figure out the best way to do stuff. I was going to suggest in a Google query to put best practices.
For Solidity?
Well, yeah. She wanted to do blockchain. She wanted to see what was the best way to do things. Best practices is a common term used to describe that kind of stuff. So I figure I'll just throw it out there. I know myself, it's sometimes hard to get the query right.
Oh, here you go. Got some more. This is probably going to be a good offering, some consensus. I would wager that there's probably some content here on OpenZeppelin. Where was it? Where was the consensus one? GitHub Pages is probably going to be good. There you go. Like these are going to be concepts that, unless you're already into Solidity development for some time, some of these are probably going to surprise you. Like me, I've been a coder for years. Some of these completely surprised me and really triggered my kind of curiosity about the whole paradigm. And again, like reiterate, I'm no expert. I'm just kind of showing my progression path so that hopefully I can accelerate others who haven't gotten as far as I have. Thank you for providing that as good context.
No problem.
Okay, do we have any other questions that haven't been answered? Thank you, Lamont, for dropping in and dropping some knowledge. And Texas, no more NPM, no more NPM is the first step. Thank you. Go. Oh, there's something we didn't get to that I definitely wanted to get to real quick. Was back in our contract, we haven't actually made any guesses, right? Where's our get? But you brought up some good concepts, right? This is a view. It's free to call. So if I say get number, I could say get. I could do this over and over and over. And you can see it's actually retrieving this variable, each time. Now, when I call guess, whether it's a win or lose, right? We're going to store a new value into either this variable or this variable. So it's going to cost us. Let's do that. So we know the winning value is 1 or is 0. Sorry. So I'm going to say 1. I'll lose on purpose. And I'm going to say 1 CFX. If we were on Ethereum, this would say 1 ETH. Now I'm going to stop right here and try to remember this number. 0.0004. Cool. Let's send it. Now, if we go here, we should see a transaction show up. Cool. I was looking at this number. We lost so that the money that we sent stayed in the contract. And it's just below 1 because if you remember from our code, we actually send back like 1 GUI to the user. Sorry, I wanted to get here and show you. On here is a bunch of data and it can be confusing. So in this Explorer, if I click view more, it'll tell me like how much of the gas was used, how much was charged. Now, this may be presented sort of differently, blockchain to blockchain, but it is important to know that like the gas fee you see in your wallet is broken up into 2 things. It's the storage fee, which is, how much you're being charged for the data you're storing on the blockchain. And then there's kind of general gas. And that is kind of like you're paying for the computation. And that's the part, if you're familiar with using Ethereum, like if it's very busy, it's going to be inflated, right? Because there's some kind of factor that understands like what is the standard gas fee currently. But your storage fee I believe it would be the same no matter what is going on the chain at any one time. Now, let's go back here. But I guess 2, I'm going to send some extra just because we need to fund our contract. And if you noticed here, we're only really, this is like a validation. It requires that this equals or is greater or equal to 1. So if I do try to send like 0.5 and I submit, it should display this. Nope. Something isn't. You must pay. So this is what I put in the contract here. You know, it could be whatever the writer of the contract kind of wants to put there. Let's bump it up again, say 10. Now, I'm just doing this again to put more money in the contract because when we deployed it, we didn't give it any coin. You can deploy a contract and put coin in it, but again, this is the easiest way to get started. Now, if I go back to our contract, it's got 10.9 CFX. Now, let's win. Just gonna put the minimum, 0. Cool. Now this is, remember I made a big deal about saying the gas is going to be equal. This is different because it's kind of like the first, we're kind of instantiating everything as we go. So I'm going to say confirm, but on future iterations, the gas charge to the user will be the same. So let me, so again, we just won with our last transaction. So our kind of magic winning number has changed to 2. So I'm going to say, I want to win again. And let's see if my assumptions are correct about our gas fee. What was our gas fee? Sorry, I missed it.
8.999.
Well, no, this is how much money is in the contract
Oh,
currently.
sorry about that.
No, it's my oversight. I'm sorry. So let's get it again. See, it did not change. This is what I wanted to show. Remember what I said earlier about you're paying for storage because you're affecting the state of the blockchain. Now, the last transaction we sent and won, it recalculated the number, but because our numbers are only allowed to be 0, 1, or 2, it actually arrived randomly back at the same value. So what we did is number was equal to 2, and we set it equal to 2. That because that was not actually a change in the state, we didn't have to pay for storing a new value here. So even when you're trying to be creative to design things on the blockchain, you still have to think about kind of these cases that are happening. But it all comes from like this concept of, you know, the cost of storage is actually right in your face, right? Like we all, if you've used MetaMask or any decentralized wallet, like you're very aware of how much a transaction costs. Any questions about this stuff? Because this was kind of what I was hoping to just really focus on. Kind of hoping there would be some learnings here. If I click into our last transaction and okay, so David, a long time ago, you're talking about like what's visible, right? 1, 2. So again, this is what the contract sent back to the user for a loss. And this is, oh no, I'm sorry. This was a win. So it's sending back 2. This is internally, the user sent 1 CFX to the contract, and then it sent, you know, very smallest amount back. I did want to show this. Please let me know if you're getting long in the tooth and everything. But remember before we had to make where we made what was called where is it? A guest event. So this is an event. And like, why do we do this? Basically, oh, this is where it's declared. And here's where we actually emit it. If you're familiar with like messaging in traditional systems, that's all this is. But what's really cool about the blockchain is you don't have to have any other infrastructure or separate code to handle like this event. It's all given to you as part of the blockchain. In traditional systems, you probably emit an event, but then you would have to have some other software to handle what to do with that. So I thought this was really cool when I learned it. Essentially, inside the log of this transaction is some data that's readable. Win is true. The winnings is, this is essentially 2 CFX or 2 Ether. And this was the value that we guessed. Now, this is actually really critical because we're playing around inside a code editor right now, or potentially, on Etherscan or ConfluxScan in this case. But if we had a website, a dApp that was sending this transaction, it wouldn't know if we won or lost until the blockchain kind of took our transaction, put it into a block, and that block is accepted and verified or executed, I'm sorry, until that block is executed and this log is produced. So this is why, if you're sending a transaction in your wallet, there's that wait time. And depending on how the dApp manages it, it can be annoying or it can be like seamless. But essentially what the website or the dApp is doing is it's waiting for this event that's tied to the transaction to be emitted, and then it's going to read like, what's the outcome? So in this case, a website that we theoretically are using would see win equals true and be like, and probably present a box that says, you won, congrats, right? It's silly and hidden, but like, it's actually pretty critical to how Web3 and blockchain works. So that's probably the last thing I should cover today. Gone a little long, but let's not stop if anybody has any questions or if you want to take the conversation about anything we covered.
How long would that transaction take?
This one, it only took a second or two. We can
Okay.
try it again. Really depends on the blockchain.
Oh, I was going to say, don't leave the casino without your bag of cash.
That's true. I mean, even if that's all about like the user experience, right? Because theoretically, as soon as you send that transaction, doesn't matter if your computer dies. And let's say you're on a website, like let's say that website server dies. It doesn't really matter because as long as the contract will execute, and let's say it was a big win in that case, and both the user's computer and the website's server died in the same instant, it would just send the money to your wallet, or sorry, to your address on the blockchain. And then the next time you accessed it, it would still be there. Cool. So
In Vegas, when you're, say, playing at the bar electronic poker or blackjack, is that happening in a similar fashion, not that it's on the blockchain unless they choose to switch the system over, but those systems are kind of, they're eerily similar in I'm just curious, is it similar in any way to the smart contract blockchain component of whatever their system is running on? Because, you know, that's been around for, God, decades. Is electronic gaming, you think, moving over to smart contracts and blockchain or not?
Ooh, that's a good topic. Yeah, let me stop sharing for now. You look at that.
Because I would think that system would run more efficiently, I would think, if it was blockchain oriented. But then again, there's the cost of blockchain, and at some point the blockchain is going to get too big and wieldy to manage unless they fork it or something. I don't know.
I think it brings up a good point, right? Is like, let's say you're playing a blackjack machine, right? All the ecosystem of that could just be that machine. Like the trend, all the interaction is going to do with you. It doesn't need communication with anything else,
Right.
theoretically. But then, okay, let's take it to the next thing. You're playing one of those. They often have slot machines where there's like, say, 10 slot machines and they're all connected to like a jackpot. In that case, like the ecosystem size is at least the number of, those 10 slot machines, because, and this is kind of a good situation to talk about, like, well, what happens if two people pull the lever at the same time on two different machines and they both win the jackpot? What do you do? And that is a concept that is more prevalent in blockchain because you have computers essentially submitting all these different transactions.
Well, it would be time stamped who
Yeah.
actually clicked first.
Yeah, and it's a bit more
But there'd
complex
still
too,
be a
because
bloody battle,
everything
including guns.
and everything is asynchronous. Like when we submit our transactions and eventually we get a response back that says you won or lost. It's there are very smart people that are kind of tackling what that means for like the parallelism of blockchain. But the design of most blockchains is core around that, like because the state is living on the blockchain and that the contract has one single state at one single time, it can manage a lot of calls to, like, thousands of people could call that same contract at the same time. And if it was designed better, or if it was designed properly, it could handle processing kind of all of those transactions in the order that the blockchain executed them and keep track of all the data involved, which is pretty impressive thing that I don't really understand. But I think that is a critical part of blockchain that really smart individuals and developers are focusing on.
So in your shell game, and of course you'd want that to be visible so people could get the sense of playing a game if they're gambling on it. Would the contract only fulfill the winning, but the actual mechanism of moving the shells and hiding the nut or whatever it is, that would be governed by another system?
That's a good question, because unless you're talking about a very high performing blockchain, a game, that's why you saw like this game, it's a turn-based game. It's sort of like, it's cards, or it's kind of one of those older kind of like turn-based role-playing games. It's easy to code for that. But you're like, I've seen some really interesting Decentraland presentations with ETH builders, and there's all kinds of craziness going on. they're finding interesting ways to manage, all the different mechanics that a real like live game requires. One thing that I started to understand from the Decentraland presentations here was like, when I was showing you those, I guess what they're called is contract calls. Like when we were saying get the number and it didn't cost anything. A game like Decentraland is sending a ton of those around the server to orchestrate all of the movement and stuff like that. And the design of like what can be accomplished via contract call that doesn't require changing the state of the blockchain, and what has to be a transaction that actually changes the state of a blockchain, I think is
Well,
critical
exactly.
in the design of the game.
Yeah, see, exactly. So if your shell game is an interesting choice because it's not just a card game, it's not just pulling up a card, you're actually moving, if it's going to work, the way it's supposed to work, in the real world, the art of moving the shells and disguising where the ball is a function of that type of a game. And that goes beyond just, okay, well, you won, you guessed it right, so now you get this.
Yeah, exactly.
So would the mechanics of that game that I imagine would be visible, like either you'd have, faux hands or something moving those shells and you're tracking where the ball is, you think?
Mhm.
That would be something that would be governed by some other mechanism, and only when the act of choosing the ball correctly or incorrectly, then the smart contract clicks in.
Exactly. I think
Got
that is probably the critical thing around game design currently is changing any of these is expensive and requires a transaction, which is asynchronous in nature. So anything that needs to be fast or reactive, but doesn't really have weight to what needs to be stored, could be executed, off chain or like within. I don't know exactly how to do it, but with Decentraland, like the calls that are going out are showing to the user change of state, but it's not actually changing anything that matters, if that makes sense.
So then would the smart contract have to have at its head end, when player chooses, it triggers the smart contract? And it's so that the smart contract knows that there's a game being played and
Yes.
needs to be triggered when a choice is made. So in other words,
Yeah,
the
and I think
the smart contract that you may appropriate from another source as a base code, you still have to link it to the game process.
Yeah.
So you have
Like
to
I
do
think,
a little
for
bit of-
example, even something really simple like a website that allows you to make transactions. A lot of them will show you something interesting while they're waiting for the transaction. Now that is just JavaScript executing in the browser. It's not anything to do with the blockchain directly. So that is a good example of exactly what you're saying, is the blockchain is not the only thing, not the only asset that the app or game is using to actually for the user experience.
Right. Web 3 may need Web 2 as a component to make it work right. Yeah.
Yeah.
Interesting.
Are you familiar with Axie Infinity?
Yeah.
That's a good example of, it's essentially a traditional game. Like I've played it. When you install it on your computer, it's its own environment. But what they do is that the assets, the actual characters that you use to play the game, are are NFTs. And what you can do is, you can put them in the game. Or you can put them like in the play zone. That's a transaction. Or you could put them in the marketplace to sell it. Like that is a transaction. But within the game, there aren't any blockchain transactions going on. You could
Yeah,
play.
you're querying a database, yeah.
So I think that's definitely like that example right there, I think is great. Like I said before, I'm a gamer, and the amount of assets that I've essentially lost forever because the game server turned off, I don't want to think about that.
Yeah, yeah.
But you think
Well,
about,
in other words,
imagine
layer
like,
2 will be necessary even as Web3 develops, because you'll still need querying databases, which Web3 doesn't do, I presume.
correct, you would have to have some sort of oracle. If you think of the blockchain as like its own network, obviously it is, it doesn't have any knowledge outside of the blockchain.
Right, right.
And that's where, like, when people say oracles, that's what they mean. It's something that is injecting data into that blockchain ecosystem.
Yeah. Can you build into a smart contract then, querying a database and coming back in? Isn't that what we were talking about before, essentially? In the beginning?
Yes.
Yeah,
To my knowledge, that's essentially what oracles do.
yeah.
Charles had a question.
I know, just a comment, when you guys were talking before about the architecture of the blockchain, and you're talking about how, what happens if you have a slot machine that has two different poles at the same time? It just might, it sounds a lot like a threading problem in Java. It just might be like a block and queue, or maybe a copy on write if they want to use lockless threading in order to process it.
Yeah, that's a great way to think about it.
Yeah, and it's actual stuff in Java that I learned. But copy on write, I'm not sure, but it sounds like a blocking queue.
Yeah, and so I think that the way that I think about it is, if you're approaching that problem in your own ecosystem with Java, you are the one implementing the ecosystem. So you're the one who's saying, you're making the rules for the blocking queue.
Right.
In blockchain, the execution environment is part of that already. So, and I guess what I'm trying to say is, I found it very interesting coding out my first smart contract, that like adapting my code to the environment that's already given was very interesting and like required creativity, which I thought was cool.
Interesting.
Yeah.
Because usually adapting code is like interfaces or extending the class or something like that.
Yeah, exactly. And I mean, to be honest, it's a little bit difficult to really know that operating environment that the blockchain is giving you. I think there's a lot of learning to be done there, and I'm certainly not an expert.
And also, one thing you may want to do, it sounds like you may want to check for like a lint tool or some sort of tool that can give you, can look through your code and say you should be doing this instead of this.
Yeah, I believe like, so this was to show basically how you could get started without those tools. But I believe like the standard tools for the Ethereum ecosystem, like Hard Hat, a lot of the NPM based modules, like was it Hard Hat and Truffle? Like if you combine those tools in the right way, you can have all the, like I said, you can have linting, you can have all the things you would expect in any language or kind of traditional IDE.
Cool.
Yeah, which is really interesting. I haven't really delved into them because I tend to focus, like I'm an ambassador for Conflux, That's why I used Conflux, because that's what I had learned first. I find like talking about the chain data like we were doing, I find that to be probably the most rewarding for the amount of effort it takes to understand, because there's so many users that don't even understand the basics of what is given to them on like Etherscan. So sometimes just explaining that will help a user start to understand blockchain better, and also make them more prepared to be like a power user.
Well, like you said, it's very different. You know, I was kind of surprised when you said take some creativity, because usually frameworks take more like understanding it versus creativity. When you said take some creativity, I was surprised.
That's a good way to put it. Thank you. Yeah, like share one more time. Like,
So would
when,
that mean, would that equate to then if you're, there's a design component and there's a coding component, and they're different structural environments needing linkage?
okay.
No,
Yeah,
I'm wondering, yeah, that was a wonder, not a
Yeah.
statement.
yeah. Probably not the best person to answer that. But like, what
Well,
I do
mean,
know
think
was when I
might
was,
be Charles might be able to speak to that.
yeah, Charles, you have further information, please.
Yeah, could you repeat it? I'm having a little bit of trouble understanding it. This is my first time with blockchain.
Oh, well,
Okay.
if you're going back to whether it's a game or it's some other kind of system or some whatever, that there's a design component to, say, creating the game, and then there's the fulfillment component of it, which is smart contract blockchain. There, if I understand the conversation correctly, then they're different design, they're different architecture environments needing linkage.
Yeah, that's what it sounds like to me. It sounds like business logic, and then the framework is a frame where you integrate into the Ethereum framework. That's what I was thinking.
Yeah. Gotcha.
And yeah, I'm just basing off what you said, because it makes sense, because the shell game is, you know, it has business logic in it, and then you're putting onto the blockchain. This is the resource you're using to you know, make sure the contracts are fulfilled.
But to make the shell game, the interesting example of using the shell game that I find fascinating is as it is a matter of hand-eye coordination to fool the viewer.
Yeah.
So it's that component, that design component, is something that would drive the usage via smart contract and winning and that kind of thing. So without the former, you really don't have the latter.
Yeah, like a producer-consumer relationship,
Yeah.
where the shell game is
Mhm.
producing the information and the blockchain's consuming it.
So for instance, you could have, if you were, say, this is kind of curious, but let's say you're a design studio, like an all-in kind of design studio, and you have a department that does design work, which is the element that you'll see, and then you have the fulfillment department, which is blockchain and smart contracts development and that kind of thing, and you're really needing to link those two departments together in the total of, you know, throwing the game out there and people playing it and then getting fulfilled, and not feeling that like they're getting ripped off or it's ineffective or it doesn't look interesting, or, you know, I'm not going to play this again.
Oh, yeah.
Mm.
Yeah, that's what they do today. You know, you have part of the architecture, you know, the business logic and all that. And then you got like the HTML and CSS where you design the screen.
Yeah.
You know, it's, yeah.
That's a
yeah,
cool
I see
conversation.
Blockchain is one individual part of this. I'm seeing it's a contract where you can communicate between two different people, and it fulfills the contract, or make sure, at least from what I'm hearing, it fulfills the contract.
Well, this might be a question for Texas. I recall Jim months ago, he had a little game that he was designing, if you might remember. And he went fairly in depth into what was underneath it. Is that still available as a replay? Texas, is it somewhere?
Yeah, I'll ask Jim about it and see which game it was.
It was a
Yeah.
numbers game. It was a blocks, as I recall, it was blocks and numbers, 1 to 100 or something like that. And he was and it was not unlike a card game, but it wasn't a card game, it was a numbers thing. as
Yeah, I
I
remember
recall.
that.
And he kind of went under the hood of how he had to smart contract that. That might be an illustrative thing to bring back up for a future conversation.
Okay, yeah. I'll
I
ask
don't,
Jim about that.
do you stash everything for replays or not?
Yeah, we have copies of everything. Currently, what we're looking for is a video editor, someone to edit our videos, and that way we can get them all posted and up on our YouTube. But I'll ask Jim about
Maybe
that.
I can help you on that.
Yeah, that'd be great.
Okay.
I'll message you in Slack. That would be very, very helpful. Thank you, David. Yeah.
Well, no, because I remember that session with regards to this, where he was dealing with very similar circumstances regarding the coding of the contract. And as I recall, some referral to whether it was an Oracle or some previous governing of how he was designing the numbers choices and things and how you played that game.
Mhm. That kind of makes sense. And I think the way I'm hearing it is I'm relating that to my experience with this was like the shell game is a super simple thing, but like to implement it the way I did was really just focusing on balancing the gas use. And that, designing the shell game took an hour and then understanding what was going on with the gas took much longer, and it was very rewarding to me.
Well, now, does that mean that are you doing something like some kind of a roll up where you're maximizing the use of gas, or how are you handling the gas fee situation?
Okay, see, that's good. So in my case, I'm actually wasting gas
Yeah, I was
because
gonna say, yeah.
I took, there's only two scenarios, right? And one required more than the other. Essentially what I did was make the scenario that could have costed less and just brought it up to the level of the highest scenario,
Well,
So-
for example, if you were betting $1, the gas might be more than the winnings. Wouldn't it?
Yeah. And it is important to say like that I thought of that and I didn't care because the environment in which I was designing this for is a very low gas environment. I
mean,
would
what's
not
on,
take
like,
this
Mac or
contract.
something, or
It's on Conflux Network. I would not take this contract over to Ethereum. It would
right.
be exactly what you don't want to do.
Yeah.
But again, that's part of the creativity is like, that's why I do believe that there won't be one blockchain for everything. It'll be like the environment provided by these different blockchains will cater to different purposes.
Sure. Yeah. What were you using for your shell game? What network?
It's called Conflux Network.
Conflux.
Yeah.
And is that designed with the maximizing use of least gas with gameplay being somewhat immediate?
Yes, it's not. So what I say, it's basically it's similar to Ethereum, but it uses a consensus. It's, to make it simple, it's a DAG. Ethereum is a sequence of blocks, and Conflux and other blockchains are DAG. It's like a tree. Blocks can execute much faster because there's essentially parallel lanes for them.
Yeah.
And really smart people have figured out a way to, to build those into a tree so that
Yeah.
everything makes sense.
DAGs are where it's at. DAGs are happening. Points and edges.
That's funny. I use trees a lot in my day job, but it's nowhere near as complex as anything related to a DAG blockchain. So I find it fascinating, but I would be lying if I understood the core
So
of it.
are DAG blockchains, is each one unique? I mean, are they built from the ground up, or are they a cut and paste job and somehow not bridged, but somehow tied to, say, a larger blockchain for record, or how does that work?
So I think generally DAG blockchains are going to be more custom designed. There certainly are ones that are just copies of the other of something pre-existing. But I think you get a certain type of like academic cryptographer type engineer that is gravitated towards those blockchains.
But are they operating independently, or in the case of, say, your game, it would ultimately be linked to a larger blockchain where the record is?
Oh,
Or
I see
is
what you're
that
saying.
DAG, or is the DAG blockchain its own record, ledger of account?
Yeah, it's so each DAG blockchain is its own ledger.
Oh, okay.
So it's,
So you could have a
Yeah.
game tied to a DAG, and it's a self-contained unit, including fulfillment of winnings and losings?
Yeah.
Ah, okay. Well, that's interesting.
yeah,
Now, in the
it's
case of your shell game, and this is, I'm curious about this because in the case of, like, if you're just flipping cards, yeah, that can be rather autonomous and it looks kind of, it's not like real life, but okay, you're sitting at a bar, you're doing that. But in the case of a shell game or something that is more designed oriented, the whole thing about a shell game is you want that sleight of hand type of thing. How are you going to get, so it's not quite like just flipping cards.
right. And I thought about that is intrinsic to a shell game in real life. Is there's usually some level of like sleight of hand, or there's like a confidence factor where people in the audience are actually in cahoots with the person running the game. But this iteration, it doesn't account for any of that. This is a fair game.
Ah, okay. To do that component, it would be far more complicated and complex to design a game where sleight of hand comes into it.
Yeah, that would definitely be complex. Yeah, I just shared for a second, but I wanted to, I shared differently, but so going back to like the transaction log, like again, I think to restate what you said is even though this is a simple game, it's a game with persistent state, right? Like each
Right.
time you flip over one of these, that changes the state of the game. It's not that each roll or each transaction is independent of each other. I think it would be easier to understand, like if say there's 100 shells, right? And there's only one winner, and that winner was worth 100 times what the cost of the game is. Then you start talking about like higher level of persistent state. And I do think, like, getting back to the logs, at that point, and I was thinking about this, is an observer could be reading the logs with the transactions going to this and just kind of essentially counting cards.
Well, yeah, and same with the
Right.
shell thing. And I see now what you're doing. So you have 3 shells in front of you, and you're just choosing which one do you think the ball is under. So you've got a 1 in, 3 shot, and then you're doing the math in your head, and then you're running the numbers and blah, 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 blah. So if you figure, okay, well, in 25 times I'm going to hit this, and you're doing that
Yeah.
kind of thing. But then that kind of takes the that takes the enjoyment of being fooled or not
Yes,
out of it. And then
it's not a
just,
social game.
yeah,
I
you're
think.
just sitting there, drinking a beer, wasting time. Okay, I'll sit here and play this silly thing.
That's a slot machine, right? That's
Yeah.
a human.
Yeah.
There's only two entities in that interaction. But yeah, like
I
was
mean, I
saying,
would think, for instance, when you go into a casino in Vegas, if say to the side of the blackjack dealers, you had like, a shell game operator, and you could kind of like sit around this thing and I think that would be really intriguing.
Mhm.
And you could have big
Yeah.
bettors, betting big money on.
like, yeah, and I think that would be like you're talking about bringing like behavioral psychology
Sure.
into it.
Sure. Oh yeah.
But I do
So
think
it's
that
much
like,
more complex than just math, you're
Yeah.
not just sitting there counting cards or.
because I mean, that's sort of like MEV on Ethereum is, to go back to the shell game example. If we had 100 shells and people were playing this game, somebody would build, a computer application that would query and just keep track of all the guesses that were made. And let's say there's been 50 guesses and none of them have been winners, then that computer program knows that, hey, I now have a 1 in 50 chance of winning 100 Ethereum. Maybe I'll start betting now. That's not all that different than what
Well,
MEV
yeah, but
is on Ethereum.
it'd be a similar to, I suppose, if you were playing, say, a poker game where the dealer was, injecting cheating into it by dealing off the bottom or something like that. But in the case of a shell game sleight of hand, there's no cheating really going on. It's the abilities of the sleight of hand manipulator, because there's still 3 shells and a ball.
Yeah.
So it's the sleight of hand along with the pattern and the whole thing and the distractions and whatever, that I don't know as a computer could necessarily guess that.
No.
Even a quantum. I mean, I guess if the computer could, if you could put some kind of visual component like eyes on the computer that would translate into binary code somehow, and maybe, but I mean, I just for the enjoyment of the game, when you bring in sleight of hand and things like that, you augment what can be computerized, I'm guessing.
Yeah.
I'm positive.
Thank you, Kwame. I hope you got something from it. Hope to see you at more ETH Builders events.
Yeah, can I do you have a quick question? Because I'm relatively new to build up the smart contract, I'm curious about if one wants to kind of launch tokens via smart contract, like what are some of the basic steps that you recommend to follow? Because we're a bunch of college kids at NYU, and we are kind of really recently we're kind of really wanting to learn how to build a smart contract step by step, and then launch our tokens to the first group of community members. So I wonder if you have any if you'd like to kind of share some basic knowledge about the logic and and the overall kind of procedure, that'll be great.
Launching a token is a common kind of tutorial purpose, and I do believe that ETH Builders would have something in the repertoire. Texas, do you know offhand of any? I think I could search through the Slack, try to find something.
Yeah, we got a couple tutorials and stuff, should be in our tutorial section in chat or in the general. But if you DM me in the Slack channel, Sandra, I'll find some links to share with you. YouTube is also a good friend also as well.
Yeah.
Okay, got it. And also do have a like a personal question about, I don't know, like what's the difference between, setting up like smart contracts on different chains? Is that like without, because I listened like the whole conversation, will that be like kind of influencing the gas fee, or like the floor price, or like what are some of the difference, like why some people are using like Ethereum for their smart contract, and why there's some people that are using Conflux, like what's the kind of nitty-gritty difference of that?
See, that's a good question. I'm trying to think of a way to answer it easily. But definitely each blockchain is going to have their own kind of gas environment. And, what the gas you're paying is some unit of the actual coin of the chain. But in the case of like, it might just be that on Conflux, let's say you might be paying the same amount of gas for a transaction that you would be on Ethereum or Polygon or anything like that. But then obviously the cost of that coin is going to change, the actual monetary value to the user, right?
Yep. Okay, I got it.
Yeah. And it's also, I like to go back to the use case of it. Like here, go back here real quick. So Conflux actually has a feature where the gas that we were paying to interact with this contract can actually be sponsored. And I've deployed this so many times, but in my video that I linked in the chat, there is a link to the original contract that I made in the video, which is this one. And I went further with this one. What I was able to do was actually sponsor all of the storage as well as the gas fees for this contract. So if I actually like write to this version of the contract, I won't be paying any gas. Now, that's awesome for the user, but it's really exists because in this ecosystem, there's a definite use case for users that want to interact with the blockchain who actually don't have any crypto. That tends to be because those users are in mainland China. And if you are aware of like what's the crypto regulations there, like a user from mainland China is not legally allowed to transact in crypto. But because they can use a sponsored contract, it allows them to do things like buy NFTs with fiat currency, stuff like that, and pretty much interact with all the metaverses and everything that you could put into a metaverse and that's based upon NFT can pretty much be done in that ecosystem without ever actually transacting with crypto. So again, that's kind of a use case that's specific to Conflux, but it's also specific to the needs of the community, if that helps.
So smart contract, like mostly they help. Can I understand it this way? Smart contracts basically help with the countries under certain like restrictions on or policy regulations on trading with crypto. Is that like what are the use cases of the smart contract?
Yeah, absolutely. Like, can you still hear me? It's frozen.
Yeah, I can hear.
Okay, excellent. Yeah, I mean, I think that's going to become more the case. Is the same creativity that I was talking about that I felt in making the simple contract. Smarter people, more engaged with what what is needed to provide a certain, experience, are definitely designing around case on many different blockchains. So, and they're definitely finding very interesting ways to, to essentially use what the blockchain gives them to achieve new and different products.
Okay, so smart contracts is more like a tool for people who cannot actually place a deal on a blockchain. So it's kind of like an assistance for the people who don't have crypto assets or like who are under like certain limitations. Is that correct?
I think that's a good way to put it. Yes.
Okay.
Because
got it.
they're going to have, like, stop me if I'm interpreting it wrong, right? Is we think of blockchain is this global thing where it's like a playground that we all get to play in equally, but we're still people who live in countries and states, whatever. Like, we are subject to localized restrictions depending on where you live. And certainly a blockchain could be used by all these different communities that have different restrictions, as long as the kind of local local compliance is designed into how they interact with that blockchain, if that makes sense.
Yeah, it makes sense. And also I wonder how what does like core research means? What does core research mean like in Web3 industry? Because I heard a lot about I just joined a conference called Ethereum as an Era, done by Ethereum Foundation, and Vitaly was actually there, and they were talking about what the panelists there were actually talking about, like the core research and how to be a core researcher, and be like zero knowledge, kind of the ZK thing. They're kind of, yeah, they were there as well. And I just wonder, like, what does like core research mean? Is there like something, because I feel like most of the codes in Web3, they're pretty much like have some kind of similar patterns or like exactly the same kind of coding languages in Web2 industry. Just like most of what we're learning right now, like HTML, like CSS and JavaScript. So I'm curious, actually, what does the like core research actually mean in Web 3.0? Is that like only the one like Japanese guy back to like 2008, like when the recession happened, like they're creating the concept of the basic concept of blockchain, or like is there any something like add on to that?
The way I think core research really goes into like the way I think about it is, think about like if you're on a Windows machine, if you're, Microsoft Windows, and you're running a game, like the game developers are like application developers, whereas the core developers in that ecosystem, I think, would be the operating system, would be the actual Microsoft Windows itself. And I think in blockchain, core developers are the actual blockchain developers who are working on the interop and how the blockchain actually functions. And the application developers are going to be more of probably JavaScript, but traditionally it would be like your dApp developers. Or even, it could also be like a traditional application that is installed on your computer that is interacting with a blockchain. That's still kind of an application in my mind, rather than the core developers will be focusing on how the blockchain actually works and the infrastructure that the application developers can use to do that.
I see. And also I have another question about like, because recently there are a lot of like news or like a lot of like note of caution in terms of like a lot of companies are being hacked, and their contract are like definitely their contracts have some certain kind of mistakes or like problems where hackers can hack into the contract and really kind of transfer the money from like different kind of portals or different like ends. So I'm curious about like based on like your previous experiences or like your knowledge, what are some of the like potential risks out there when kind of building up your smart contract in order to not be like hacked? Because like why those kind of phenomenal companies who have like kind of millions of dollars of transactions, they're still like get hacked. And like I think this is like it's just really kind of abnormal to have this such like very big kind of market cap, but also not protecting the smart contract well. So I'm curious about what will be like the kind of basic risks when building up the smart contract, or like the reason why they get hacked.
Yeah, he's back. He dropped for just a second, Sandra. But yeah,
Okay.
like
Okay.
David said, don't build a financial debt. That's a joke,
Okay.
but yeah, that is a good question. And honestly, like honeypots, true. But that definitely is a question on every developer's mind: is being hacked, or how do you get hacked, and how do we avoid hacks? So that's why earlier, whenever you heard them talk about OpenZeppelin, the smart contracts, they're audited, they're good. That's one way I myself look at to avoid being hacked. But then, you can also hack into your website or go from there with it. So when you look into that part of hacking, to me, that becomes like a multiple question about where you're at within the hacking part and in your vulnerabilities and things of that nature in your smart contract. So that's where it starts taking me down a rabbit hole.
Oh yeah, like and also because I just joined like another conference called SmartCon by Chainlink. So they one of the kind of one of the companies like showing up there, they say that they actually like met like a person, and that person was very kind of honest, saying that like I'm actually a hacker, and I hack a lot of people's money, and and I'm super rich. So it's kind of yeah, so it just like now like I feel like hackers are like so obvious, and they're kind of so daring in terms of like how to they kind of I just like really like there's like I just don't know like how they hack into people's addresses and really kind of transfer the money there, because I feel like, well, technologies are there to be learned by everybody, but why like hackers can hack to is there like some kind of basic or some kind of nitty gritty hacking technique that like most of people don't know, so they get hacked? Or like I just feel like, yeah, is there like actually a way to kind of protect yourself like anyways? So yeah, I just feel like this like that kind of story actually intrigued me to like think of like the hackers and the hacking mechanism and some kind of like the meat of like, yeah, just safety and privacy if you're Web3 assets in this industry. So yeah, I just feel like, and personally I got hacked a couple of months ago, so it's not like a lot of money, but I just feel like, yeah, it's just really bad, and I feel like super insecure like when my address got hacked, and I just don't dare to use that address anymore, and just like, yeah, so just yeah, just kind of like hackers are very they're just like very maybe proud of themselves. I don't know.
Yeah, I can take that one. I'm sorry to hear you got hacked. That is terrible feeling. And I was kind of relating your question back to what you were asking about earlier about core developers. Like, I think from the majority of hacks that I've seen, the kind of attack vector or the entry point has been something kind of traditionally Web 2. Like, someone is able to steal a domain of a DeFi app, and then when someone goes to that domain and they click on deposit, it's actually changed like what that button is doing. It's gonna send that money to a different contract. So I think most of what I've seen are entry points like that are traditional or part of the infrastructure of just the internet. But I was following what happened the other day on Binance, and some real people that were, so basically there was an exploit and more BNB had been minted than should have by a bridge mechanism, and they actually paused the chain to figure out what was going on. And what was really scary about it, which I heard from people that are smarter than me, so I'm just kind of relaying what I heard, was that it actually was a cryptographic hack, in the sense that a proof that basically the blockchain validates a proof to kind of confirm that the data it was given is valid. Someone was able to figure out how to create a proof using kind of older data. And that worried me more than any of the ones where it was like someone hijacked a domain or an email address. That to me was the cryptographic one was a little bit scarier, because that is really the domain of the core developers, right? So David was asking if it was minted or withdrawn. What I know was it was the bridge that connects Binance Smart Chain to Binance, the actual centralized exchange. And the net result was someone was able to create a bunch of BNB that wasn't, accounted for on the other side. Just try not to use technical words improperly, because I don't know the full story. But what I read about it was that it basically the transactions were sent to this bridge that validated on the blockchain, and the way that it was done, people don't understand how it happened, and it was scary, because it sort of shows that the attacker was very advanced in their approach.
Yeah, just like a little confusing, because like why like people are building a smart contract with the same techniques, but like how hackers being super like more advanced in terms of being just going above and beyond, and really kind of knowing all the basic logic of like building up the smart contract, but also know how to hack. So yeah.
Yeah, those are good questions, Sandra. And definitely, I do thank you all for coming out today and everyone for showing up. And I do appreciate the lessons and knowledge that we've been able to learn and exchange as well. Those are some good questions you had, Sandra.
Yeah, thank you so
hey.
much. Oh, sorry.
No, you're all good. There was an interesting one. So I was following what do you call it? Ethereum proof of work after it forked, right? And because a lot of the other stable coins on the chain had absolutely no value, their value completely collapsed. And so I was trying to find what coins might have value over on ETH proof of work. And one of the ones that was holding stability for a little bit was LUSD, which is Liquidity, and the fork, because that protocol happens to use ETH to mint a stablecoin. And I was on the chain, so I was actually noticing that it was holding some value, and so I was actually trading into it from the ETH proof of work that I had received from the fork. And then all of a sudden, within like a day or two, I noticed that all of a sudden, somehow, somebody was able to exploit a contract and mint 500 trillion or something like that LUSD from the protocol. And obviously, the protocol was broke because it uses two oracles. It uses both Chainlink and Teller, and the Chainlink oracle went down. But somehow, apparently, they figured a way, because I guess the way that the protocol worked is it would basically, if somebody posted a wrong price on Teller, that the protocol would then recognize that that oracle as being true and adjust its price. And so somebody figured out how to issue out false oracle data from Teller to allow them to mint the like 500 trillion LUSD with one ETHW. And then what they did is that they took that supply, deposited it in the stability pool, and then after the correction, allowed them to basically withdraw all the ETH proof of work in there. And I traced it back and basically watched them funnel all that out, or a good portion of it out back to FTX to extract and then sell. And they took out about 6 figures worth of ETHW proof of work out of it, which was pretty fascinating to watch. And it was like, God damn, I wish I knew how they did that. And it was interesting because a lot of the contracts had needed to be republished because they weren't available through the Explorer to interact with. So it was very interesting, and I was bringing this up over the Discord, going, guys, like, what happened? After, nobody really seemed to care, but there was a few people who kind of explained and said that it looks like, based off their knowledge, that there was a misuse of the oracles. And so when Chainlink failed, it opened up an opportunity to therefore exploit the protocol. And so obviously it's an issue that they needed to address in case there was ever something similar to happen on Ethereum. But it's fascinating to see when things break, how people quickly exploit them.
Hey, David,
Yeah.
did that mean that real people lost real money, real ETH?
You lost the fork. Like, so if you had, so I mean, it's free money, right? So when ETH obviously went to proof of stake about within the last like a month. Well, when ETH went to proof of stake, somebody forked the project off, right? And so everything that you had on ETH on proof of stake was exactly cloned on ETH proof of work.
Right.
And so if you had a trove or a debt position in the protocol, that protocol is now forked. Well, all the debts you had in this new chain are also forked, right? So you would potentially still have ETH proof of work locked up into this protocol. If you had a wallet that had ETH in it, you had a fork, or you had duplicate ETH in your wallet. And at the time, I think ETH was about $5. Now it's about $10. The ETH proof of work was $5. Now it's about $10, and you can sell it on Kraken.
Oh, so what you're saying is the people with ETH in their wallets didn't really lose their ETH.
No, they didn't lose their
These
ETH. They lost
guys
the
were
forking.
these hackers were able to duplicate that and liquidate that.
Yeah.
So they
it's the
created
fork
money where
protocol.
it didn't exist. Oh,
Everything I'm
brilliant.
talking about is on the fork protocol. So I mean, technically, you people had debt positions. People have money. Like if you had 1 ETH in a wallet, in a hardware wallet, you still have 1 ETH proof of work in that wallet. Now, what was interesting is because people had taken loans out and stuff like that, those loans were still sitting there in this fork protocol. So what this person did is they minted out a whole bunch of LUSD by exploiting the protocol, deposited it within the protocol to help force liquidation. Because what happens is the way liquidity works, it liquidates when there's a liquidation. And obviously there was a liquidation because the ETH proof of work price was like $5 or $10, where ETH was originally trading for about 1,300, right? So from 1,300 to 5, yeah, it would automatically liquidate. But the way liquidity works is it will instantly liquidate all the accounts, but then all the debt positions, if there's not enough collateral to back it up, it actually consolidates. And so you have all the ETH, and all the LUSD, and all the ETH proof of work that's backing it ends up becoming concentrated into one pool, but it's under collateralized, and so it can't do anything further. So what the account did is the account basically allowed themselves to mint a 500 trillion somehow by adjusting the price, falsifying the price, allowing themselves to mint that and then deposit it into the stability pool to then liquidate the other account. And the moment they can liquidate the other account, they can then basically use the stability pool to buy up all the ETH that was in that pool. And so they ended up picking up about 6 figures worth of ETH out of liquidating the other account through the stability pool. And it was just like, it was pretty ingenious.
So it's still there technically, or did they actually?
Oh no,
convert
I
it to
watched the
fiat?
wallets. The stability pool, they put the money in the stability pool, liquidated the other account, reconsolidated it, and basically pulled out the ETH. So they pulled out 6 figures worth of other people's ETH that was deposited in the protocol before.
And they converted it out to fiat.
Well, they sent it to FTX and sold it on FTX.
Wow.
Okay, that's what I was
all
gonna
that
ask.
can be tracked, right? But who's
Oh yeah, that's how do you think I figured it all out? Like I was
no, but what I'm saying is, what I'm asking is, who's responsible for that? Is that the foundation ultimately that's
Oh
gonna
well,
take
I
the hit?
mean, everybody said that they're not supporting the platform, right? They're not responsible for the protocol, and they're
Oh, okay.
they already acknowledged that that up front. But the thing is that these are DeFi projects, right? Once they're launched, they're there permanently. And so it's
And you were watching this in real time?
yeah. I was actually
Oh, that's fantastic.
I'm sitting on a whole bunch of LUSD over there. And I was playing with it because I was like, hey, if there's going to be a stable coin on this platform, it's going to be this protocol because it's the only one. Now, somebody's already forked the protocol and created a new one out there. And I wasted money on this, but it was fun watching it, participating in it, and seeing what happens. And I mean, who knows? It's a protocol. We'll see if it comes back. Just depends on Teller and whether they fix issues. But I think it is an issue at this point.
Well, I take it if you were watching it, that meant others were as well.
Well, no, I'm sure other people are seeing it, but I mean, like nobody was really addressing the question because I was talking to a few other people because, for about a day or two, it was actually it was the only stable coin holding its value was LUSD, until somebody figured out how to do that exploit. And so I was actually sitting on a good chunk of it at the time because I'm like, hey, look, if this protocol continues to work like it's working, eventually this is going to, basically be the legitimate stable coin on this platform until somebody literally wiped it out. So now somebody's already forked the project and I believe they fixed the problem. So we'll see if they've actually fixed the problem or not. They said they kind of did some other stuff on it, but I'm always like,
Did you lose any of your stake or was it a dupe?
I lost I mean, I lost value in LUSD because I was trading into LUSD before it collapsed.
Yeah.
So I mean, I've lost, but I mean, the thing is what I lost is I was, putting, $300 or $400 worth of ETH, and so it was,
Play money.
You play in DeFi, you're gonna expect to lose some money.
Yeah. Well, that's fantastic.
So, but it was fascinating to watch, and it was like, wow, but there was a problem here. Like, let's figure this out. And so there was, some discussion in Discord.
You should write that up and tweet it from your Twitter account.
Oh no, I did. It's all no. Trust me, I put a whole bunch of feeds on there. I was like tweeting at the company, going, "Hey, somebody just withdrew 600 figures out of your fork project. Somebody should understand this and want to know what happened." Like, and so we got to the answer, and the best answer that I saw was that it was likely, it was the Teller protocol. It was the fact that how Liquidity looks at Teller and did not wait for a validation of price, but just accepted the Oracle price from Teller. And then they're also not only that, but Teller also had a problem where it only goes out 6 decimal points. And so when they were able to exploit the protocol, they were able to, I don't know if they fudged the Oracle price on the ETH or if they fudged the Oracle price, it broke the Oracle price on LUSD, one or the other. But right now the LUSD goes out like 9 decimal points. So yeah, it's pretty interesting. And Kyber Swap was really the only Oracle, only a decentralized exchange you use to swap. So we were swapping through Kyber Swap, which actually utilizes multiple dexes to swap.
Wow.
So it's a fascinating playground. It's still, I mean.
So what would be the lesson learned from that, do you think? If you put it into a 25 words or less, what's the lesson learned?
Chainlink is very important to DeFi. That was a big lesson. that shit breaks when you don't have chain link at play.
It's interesting. So is it
I mean-
a correct takeaway that the two factors that made that possible were the fact that an oracle was involved, that's like external data, and then I'm also assuming that it wouldn't have mattered if no exchange like FTX ever started accepting deposits of LUSD as equivalent to LUSD from
Well,
Ethereum, right?
There was incentive, right? So the moment somebody can exit, I mean, Kraken could have taken it too. The moment there's incentive to exit money out, people will take the incentive to see if they can exploit it. And here's the thing: the funny thing is somebody obviously has to know that protocol real well, because as I was saying earlier, the contracts were not, they didn't show as published on the Explorer, because I was trying to figure out how can you. A couple of people were trying to figure out how can you interact with the stability pool, and withdraw any liquidations, right? And the thing is you actually couldn't work with the smart contracts because they had to be republished. So you couldn't write a contract from the Explorer. And so I was like, well, then how the hell does somebody do this? So either somebody compiled their own front end to interact with it, or they knew how to operate the code within a smart contract directly already, which means they have fairly good knowledge about the protocol before it crashed, right?
So is the code able to be amended then by anyone, or
Well,
wouldn't
there's
that
the smart
need to be-
contracts. If if you wrote a smart contract on ETH proof of stake and you know exactly the code and you know what needs to be called, you could have written it on ETH proof of work. So whoever did it had very good knowledge of the protocol on ETH proof of stake before, that did this on the ETH proof of work. They just knew what to call.
But wouldn't that mean that you'd have to break into the blockchain to republish? I mean, it's like.
No, you don't have to break in anything. You just have to publish code. So somebody knew how to publish a contract to be able to do what they needed to do.
Basically eradicate the prior code. Yeah. Wow.
Oh no, they just interact with it.
Yeah, that's
So-
crazy.
But yeah, so it was pretty fascinating to see that happen. And I think we think that's the most logical thing, is that they were able to exploit the Oracle, and they kind of acknowledge that was an issue, which is good. I mean, that's the real thing is we need to know what breaks and why, and what would it take, because yeah, that means that there is potential, that potential vector. But I mean, luckily it's a secondary for them as a backup, but you want to make sure your backups work too.
Is
So
that
it's-
adding more fuel to the fire in the argument between the POW and POS?
No, I mean, everybody knew proof of work was going to have a lot of broken prompts because the Oracle said they weren't going to support it, which is a shame, because I'm more of a fan of proof of work for security and decentralization purposes. But I mean, it's, it was fascinating to see. It would be interesting to see. I mean, we are really reliant on oracles, and so it would be interesting to see a system that was more laissez-faire, which means let the markets kind of do their own thing, and because we have so many liquidity pools, somehow create an oracle based off of the liquidity pools and let the market dictate what the price of something is, versus having oracles do it. But
That's interesting.
yeah, I don't know.
But then wouldn't
hard.
that set up a potential security problem that if the one liquidity pool was cracked, everything falls apart?
Oh yeah, absolutely. No, yeah. Well, no, the issue there is that liquidity pools that don't have enough liquidity can easily become unbalanced and throw the value of one side off versus the other. And so there's definitely issues in that. And that's where it is good to have some oracle that says this is the prices, just because you can have imbalanced markets. But personally, I think imbalanced markets are good, because then you'd have people who would program bots to fix those imbalances and rebalance the market, because they see arbitrage opportunity. So in my theory is, if you had markets that were healthy markets, where they interact with one another, and you relied on those markets for pricing, if there was any arbitrage opportunity, those markets would self-correct themselves to actually balance out the market. And therefore they could be a valid oracle just because any opportunity for arbitrage would be eaten up out there, which is why gas prices often get so high, is because you have bots fighting against each other for those arbitrage opportunities. So in theory, it may actually work.
Would that also perhaps offset some gas fees if you were having independent liquidity pools playing off of each other?
What do you mean?
And you could almost
No,
arbitrage
that does not help
gas
gas
fee,
fees at
couldn't
all.
you?
That makes gas fees worse. So, but it's it's interesting. I mean, Ethereum is not meant for a whole bunch of transactions. I don't think it was meant for arbitrage markets and all that stuff.
Yeah.
I definitely want to thank GLM today for coming out, and I do thank you all for coming out today. And
Thanks, Jalen.
yeah, I guess we can call it a day for today, and we'll be regrouping soon as well. And be sure to stay in touch in the Slack channels and on the Discord and whatnot. And we definitely look forward to seeing you all soon. Thanks for coming today.
Yes, then thank you again, Texas. This was an amazing opportunity, and I'm so glad that the conversation, it was a real conversation. I think that was something that tends to happen with this group, and I've learned so much from it. So go ETH Builders. Thanks for the opportunity.
You're most welcome. Thank you.
All right, I'm gonna drop now, guys.
All
Thanks
right.
again.
Thanks, TF.
You're
I'll get
welcome.
back to you on the video. Cheers.
Okay, that'd be
Good seeing
great.
y'all.
Bye-bye, everyone.
Bye,
You're
everyone.
welcome. Bye-bye.